Here we are, intro number 9, the last video in this introductory unit. We're really going to cover a lot of various problems, but the ones that I want to look at in particular are finding 6 trig values given one value or a point on the terminal side, using the binomial theorem, finding the area bound by a curve, and then some other kind of review problems. All right, so let's try and find all 6 trig values if we know that the sine of alpha is 5/13 and alpha is in quadrant 2. Well, with alpha being in quadrant 2, what we're saying is that it's a position angle where the terminal side is in quadrant 2. So something like this. This is alpha. Since the sine of alpha is 5/13, we can draw this little triangle in and use the reference angle to help us identify all the trig values that we need. Now, since we know about sine of alpha is 5/13, sine is opposite over hypotenuse. So we got 5 and 13 as side lengths to this triangle. Then, to find the last side length, we could just use 5 squared plus x squared is equal to 13 squared, and we'll end up with x being 12. So we know the base of this triangle is going to be 12. However, since alpha is in quadrant 2 and we moved back 12 units, we have to give this a value of -12. And this is going to be enough to find all 6 of the trig values. We already know that sine of alpha is 5/13. But now when we look back to the triangle that we have in green, we can identify the cosine because it's going to be adjacent, the -12, over hypotenuse, 13. And for tangent, it's opposite over adjacent, so 5 over -12. Then we finish it up with our co-functions. So we got cotangent is going to be the reciprocal of tangent, so -12/5. Secant is the reciprocal of cosine, so -13/12. And cosecant is the reciprocal of sine, and that gives us a value of 13/5. Let's try that one more time. Let's say we know that cosine of theta is -1/4 and that theta is in quadrant 3. So theta is down here. This is theta. And we draw that reference triangle back to the x-axis there, and think of theta as being that central angle. Now cosine is -1/4, so -1/4. The radius or that hypotenuse is always going to be a positive number, but because we're back in the third quadrant, that base of that triangle is going to be -1. But we need to find out what the other side of the triangle is going to be. So a little Pythagorean theorem here. We got -1 squared plus that y coordinate squared is equal to 4 squared. So y squared is going to be 16 minus 1, which is 15, and y would be the square root of 15. Since we're in quadrant 3 and that y coordinate is going down, our square root has to be negative. So we have enough for our 6 trig values. Sine is going to be opposite over hypotenuse. Cosine was given as -1/4. And then tangent is going to be opposite over adjacent. So -√15 over -1 is going to end up being +√15. Then our cofunctions, cotangent of theta is going to be the reciprocal of 15, so 1 over √15. Secant is the reciprocal of cosine, so that'd be -4, and cosecant is the reciprocal of sine, -4 over square root 15. And it would be okay if you left our fractions like that, or if you wanted to rationalize the denominator, you could do that as well. A variation on that same problem is, what if we know 3/4 determines the position angle t? Can we find all 6 trig values? Well, we know 3/4 is going to be about right here in the first quadrant. So by 3, 4 determining the position angle. It's an angle that's in standard position. So its initial side is the positive x-axis, and its terminal side is going to run through that point, which means our angle T is right here. Then, just like before, we're going to draw this triangle to give us a reference. We know that the base is 3 and the height is 4 from the ordered pair that we're given. We could do Pythagorean Theorem or just recognize that it's Pythagorean triple. This is the old 3, 4, 5. And now we've got everything we need to find our 6 trig values. Sine is going to be opposite over the hypotenuse. Cosine is adjacent over the hypotenuse. And tangent is opposite over adjacent. Then our cofunctions, cotangent is the reciprocal, so 3/4. Secant is the reciprocal of cosine, 5/3. And cosecant is the reciprocal of sine, 5/4. What if we want to find out where A is? So find that ordered pair for A. This one seems very similar, but it is a little bit different. What we need to remember is that for any ordered pair, when we're given that angle, it's going to be cosine sine. So cosine of the angle and sine of the angle. If that point is more than 1 unit away or different than 1 unit away, we also have to multiply by r, the length of that radius or the hypotenuse there. So in this case, we are going to need to first identify what our cosine is. The r is 9, and we want to find cosine of 5 pi over 6. So whatever trick you use about finding the cosine of pi over 6, cosine of pi over 6 is going to be root 3 over 2. Now, since we're talking about 5 pi over 6, and cosine being the x-coordinate, that's going backwards. So we'll have a negative value for that, which means our cosine of theta is going to be negative 9 root 3 over 2. And our sine of theta is going to be 9 times the sine of 5 pi over 6. The sine of a pi over 6 angle is going to be 1/2. And for 5 pi over 6, it's in the second quadrant here. It goes up. That means it's going to be positive. So our y value is going to be 9/2. Then we can state what A is. A is the ordered pair, negative 9 root 3 over 2, and 9/2. All right, shifting gears here, using the binomial theorem to expand x plus 3y to the 4th power. Now, this is something that we usually spend some time in pre-calculus with. I believe we spent some time on it last year, but it's been a while, and nobody's ever really good at it the first time through. Now, to use a binomial theorem, there's going to be a handful of terms, and every term is going to have the same 3 parts in it. It's going to have a coefficient, it's going to have x to a power, and it's going to have 3y to a power. The coefficient is actually a combination where we start with the power, that's always that number that's on top, and we're going to start with 0 right here. To find the powers of the next 2 factors, the power of the 3y is the same as that 0 in our combination. And the x is going to be 4 because 0 plus 4 is this 4. Now we move on to the next term. It's going to start with a coefficient, x to a power, 3y to a power. 4 is always in the top. But now we're on to the next term, so instead of 0, it's going to be 1, meaning 3y is to the first and x is to the third, because 1 plus 3 is 4. And we continue this pattern all the way through. So now it'll be 4, 2, which means 3y will be to the second power and x is to the second power. Then 4, 3, 3y would be to the third power, x is to the first power. And our last term is going to be 4, 4 with x to the 0 and 3y to the 4th. Now we need to start calculating. 4 choose 0. Technically, what that means is 4 factorial over 0 factorial, 4 factorial. And then we'll have x to the 4th. The next term is going to be 4 factorial over 1 factorial, 3 factorial, because those two factors in the denominator have to add together to that numerator. We'll have x to the 3rd times 3y to the 1st. And 4 factorial, 2 and 2 down here, x squared, and 3y squared is 9y squared. Our next term. Want to make sure it doesn't get too crowded here, but we're on to 4 choose 3. So 3 factorial, 1 factorial, x to the 1st, and 3y to the 3rd is 27y to the 3rd. Last term, 4 factorial over 4 factorial, 0 factorial, x to the 0 is 1, and 3y to the 4th would be 81y to the 4th. Lastly, we just have to calculate. So 4 choose 0 is going to be 1. 1 times x to the 4th is x to the 4th. 4 choose 3 is 4, x to the 3rd times 3y. 4 choose 2 is 6, x squared, 9y squared. And then the thing about these combinations is that once you get past the middle, there is symmetry there, so that 4 choose 3 is also going to be 4. And 4 choose 4 is going to be 1. So that symmetry that I'm talking about happens here with our 1 and 1, and then the 4 and 4, and 6 is in the middle. But now we can just finish it up. X to the 4th plus 12x cubed y plus 54 x squared y squared plus 108 xy cubed and 81 y to the 4th. And that's how you use the binomial theorem to expand a big old polynomial like that. All right, let's find the area of a region bound by f of x equals the absolute value of x minus 2 on the interval from -2 to 5. Well, f of x equals x minus 2 is that absolute value function. It's that v that has an x-intercept at 2. The slope on either side is going to be 1, but we want to go from -2. So if I were to plug -2 in there, f of -2 is going to be the absolute value of -2 minus 2, which is 4. And on the other side, for 5, so f of 5 is going to be absolute value of 5 minus 2, which is 3. And so our graph looks like this. And we want to find the area of the region bound by that curve and the x-axis on the interval from -2 to 5. So what we're really looking for is this area. Once we have the picture, we see that maybe it's not all that bad. Right? That we're just really trying to find the area of two triangles and add them up. So to find the area of the triangles, I need to know the base. And in this case, when we go from -2 to +2, that has a length of 4 and a height of 4. And then from 2 to 5, that has a length of 3 here, and then also a height of 3. So that total area is going to be 1/2 base times height for the first triangle, and 1/2 base times height for the second triangle. 16 halves is 8, and we have 9 halves as well, which altogether would be 25 halves, or 12 1/2. Then one last review problem here, finding a value for x. Remember that what we have are two similar triangles. Our first triangle being the larger outside triangle, and the second triangle being the smaller one on the inside, right here. And the thing about similar triangles is that the ratio of corresponding sides is the same. So if we're going to go from big triangle to small triangle, so these two bases, the big side is related to the small one in the same way that we look at the sides. The big side would be that sum, x plus 3, is related to the smaller side, down here, just the 3. Okay. The biggest problem that calculus students have in this problem is they want to go 9 is related to 2 in the same way that x is related to 3. But that's not true. It has to be that x plus 3. But anyway, now we cross multiply, and actually just multiply both sides by 3. And we'll have that x plus 3 is 27 halves. And subtract 3 from both sides. Just 6 halves. So x is 21 over 2, which is 10 and a half if you want. So anyway, that's a lot of problems, a lot of different types of problems all at once. So take your time, go back and review as you need.